Our next unit is on linear functions. This unit, good amount longer than the one before. Haven't decided for sure when y'all's test will be, so I'll let y'all know as soon as we get that figured out. So let's start with this here. Got two triangles. Who can tell me which triangle is steeper? Sari? B? Why you say B? The length on the bottom makes it steeper? Robert? Hmm? It's a little more square. Lacey? Why is B steeper?
Because the line is going more straight down than the other.
When we're looking at the steepness, we are looking at this angle of that line right there, that side right there on these triangles. Both of those triangles, the sloped part is going up by the same amount. They're both going up 8 feet. The difference is along the bottom there. Since A has a longer distance on the bottom, it's making that one less steep, right? All right, so I used the word we're going to be working with to start with to describe that, slope. You've heard slope for like ramps and angles, maybe even hills, stuff like that, right? So mathematically, what we got is when a linear relationship, so a linear function is graphed, the slope is a value used to describe the steepness of the line. The higher the slope is. So like angle B there, angle B had a higher slope. It was more steep. A was a little bit flatter. That's a lower slope. Slope is a ratio. That part's maybe not super vital, but what it is the vertical change compared to the horizontal change. Really what we want to use is what it says there, rise over run. You are going to hear that a lot throughout this unit. Rise over run. Yo, rise. Which way is rise going to go? Up. Here's the thing. Mathematically speaking here, it's going to go down also, okay? So rise will be up and down. So rise is how much they go up and down. Run then is side to side, okay? Yo, what axis goes up and down? Y-axis goes up and down. Left and right is the x-axis. So we'll get more into that in a second, but change. Y'all worked with rate of change last year. Y'all worked with it in 6th grade a little bit. 6th grade, primarily the rate of change was unit rate. Same with last year, it was primarily just unit rate. Well, they add a little extra to this stuff, so it's not just going to be a unit rate, okay? All right, so we have 4 different types of slope. So to start with, this line here, When you look at a line that is graphed, you look from the left to the right. So as I move from left to right, am I getting higher or lower? Higher. So what that means for my slope, that is a positive slope. As you go from left to right, if it moves upwards, that makes a positive slope. It doesn't matter if it was all in the negative numbers of the graph. If it's moving upwards from left to right, that makes your slope positive. All right, so what's happening in this one? Going down, so what's that mean for the slope? Yeah. When I type it out, it doesn't exactly fit in the box or the space, but it's probably easier to read than me trying to write. All right, so now we get maybe a little trickier or a little different. How do we describe that line right here? Horizontal. So when we have a horizontal line, when we have a flat line like that, what that means for our slope is we have a zero slope. So we said before, slope is rise over run, right? So when I have a graph like this, it's got no rise, and depending on where we put it, any number for the run. So when I have 0 divided by a number, that's 0. That's where the zero slope comes from. All right, so then the last one here, a little different too. Oh, don't want to fit in one line. That's an undefined slope. So when I have a vertical line, we got an undefined slope. What that does is that flips it around. It's all rise and no run to it. Right, so that means we're going to have a number divided by 0. Okay? How many times does 0 go into something? No, it goes into it infinity times, actually. It's an infinite amount, basically. We can't divide by 0. If I have you empty out your pockets and then take a handful of nothing and keep putting nothing into your pockets until they're full, are your pockets ever going to get full? No. You'll be doing that forever. And nothing's going to fill that up, right? Because 0 goes into something infinite times, basically, is the dividing by 0. Any questions? Everybody got those so far? All right. Slight mistake on the formatting. They've been flipping my lines sometimes when I group them. All right. On your paper somewhere, draw this picture of Olivia. No, not Olivia. This is Slope Man. Our Slope Man here has an eyebrow with a positive slope. Eyebrow with a sign on this eye. A vertical line is undefined. Mouth. I guess those are dimples that make the zeros because a horizontal line has a 0 slope. So it's the, I don't know, just a dumb little way that can help sometimes remember which slope's which kind of thing. So that's Slope Man with the 4 different kinds of slope to them. We got it? All right, so now what we're going to do for today is we are going to find slope from a graph. We'll have to do it from ordered pairs, we'll have to do it from word problems, and all sorts of other stuff like that. But we'll start off with the graph. So when you're finding slope from a graph, you need 2 points. Have to have 2 points. Will some graphs have points you use? The slope should be basically then you're making a right triangle to get the rise and the run. Set up your ratio or basically your division problem there and simplify. So you get your rise over your run. The rise. You also have to pay attention or double check at the end if the graph is positive. What we need to do is we need to pick 2 points. All right. Any 2 points work, but what you want is 2 points where the line is going through corners. All right. So when we have our grid lines, this point right here, that's not going through corners. Everybody see what I mean? So we could use right here, right here, right here, right here, and right here on this graph. Everybody good with what I'm talking about by corner? What they're going to do is connecting those 2 points. You go up and over, up and over. I'm just going to draw all of them. Like I said, we only need 2 points. So, you see what I mean? So then what we do is you count the squares. Your rise, how much it goes up. Your run is how much it goes left. You also want to pay. So if I use like right here, I'm going from 4 to 6. So that's a rise of 2. My run is going from 2 to 3. So that's a run of 1. Slope is rise over run. Y'all, what's 2 over 1? 2. On a lot of these, you're going to end up with fractions. Better for slope than decimal. All right? Leave it as a fraction. Don't change it to a decimal. If you get an improper fraction, a whole number, Leave it as don't make it a mixed number. Those things make slope a little more complicated. All right, so we got 6 here on the back of your sheet. See if you can find the slope. If the slope is negative, your answer needs to have a negative sign. Basically, when you do rise, Lacey, 1/2 is correct. A lot of tracks, not always though. And we're doing our rise and our for my rise, I'm going there. Run, I'm going there. So my rise is 1, is 2 slope, or 2. So negative 1/2. Number 2, Robert. 0. To do is recognize the flat line is 0 slope. All right, so we follow that up with probably the toughest one on here. Number 3. 6 is correct. All right, so the reason this one is the toughest, I think, is just because it's a little trickier. If we use these 2 points right here, I got rise, I got run. The big mistake a lot of people make is they say the rise is 2 and the run is 1 because you go up 2 squares over 1, right? You have to pay attention to your labels. I'm going from 3 to 9, so that actually makes my rise 6 and my run is 1, so it's 6 over 1. That's where the 6 comes from. Four. I was mixing it up. So you said 1.5. As I said before, we're going to keep that as an improper fraction, okay? That makes 3/2 or 3/2. So our rise and our run, we got up 3/2. Okay? Number 5. Robert? 1/4 is correct. At that point, the next one through right. So we got 1/4, that's 1/4. All right, last one then, number 6. Oh my goodness, really? There we go. Wait, Pedro, what'd you say? Oh, sorry. All right, we got a negative slope. Y'all just ain't listening very well. And we're changing them to mixed numbers, and that's messing me up, sorry. So we got negative 4/3. All right, again, keep these as improper fractions. If you make these decimals, if you make these mixed numbers, you will be making a lot of things much, much more difficult for you throughout this unit. You want to make sure you are using improper fractions unless like it specifically has something different in the problem. All right, so I just wanted to go over this one, similar to what we had before with number 3. Makes sense, right? Is correct? No, over 2. Okay? Any questions?